Today we're going to talk about an expression that's known as the discriminant. So the discriminant comes from the quadratic formula. So first, let's review the quadratic formula. X equals, finding the roots, x equals negative b plus and minus square root b squared minus 4ac all over 2a. So, of course, you already know that finds the roots of the quadratic equation. Inside the quadratic formula, underneath the radical, is b squared minus 4ac. b squared minus 4ac all by itself, sorry, it's getting loud here, is the discriminant. There it is. All by itself, no radical. And that gives us information about the roots. In other words, it tells us what these roots, if we solved, what they would be like. We'd be able to describe them. You will see in a lot of problems that's known as the nature of the roots, the nature of the roots. So let's go ahead and sort of figure this out and think about if this kind of number was under the radical, what kind of roots would I get? This is all about the nature of the roots. All right, here we go. I'm going to keep this like this. If our discriminant, so if underneath the radical is greater than 0 and it's a perfect square, greater than 0 and a perfect square, numbers like 16 or 100 or even 1 under the radical. So if that's the type of number under the radical, then the radical simplifies perfectly. This would simplify perfectly, and I'd have negative b plus that number, negative b minus that number, and both of those divided by 2a. I get roots that are real. They're real numbers. Better than that, they're rational numbers. That means they look nice, they're clean, we know exactly what they equal. There will be 2 of them because of the plus and minus, and they will not be the same, so we say they're unequal. When we graph one of these, we get a parabola, and the parabola hits at really nice points. I'm just going to make a couple up here. I'm going to say this hits at 0 and 4. Really pretty points, and that's that rational part right there. So we have 2 intercepts on our graph. 1, 2. So let's follow that same train of thought for the next possibility. b squared minus 4ac, what's under the radical, is still greater than 0, so it's positive, but it's not a perfect square. So underneath the radical, something like 17 or 40 is not a perfect square, or even 2, not a perfect square. Well, if that's the case, then let's look up here at our quadratic formula. This is not a perfect square. The radical does not simplify. So we're left with a radical in our answer. They're still real, but now they're irrational. There's still 2 of them, and they are still unequal. So when these types of quadratics are graphed, we still get 2 intercepts, 2 unequal roots, but now these roots are going to be things like 1 minus square root of 7 and maybe 1 plus square root of 7. I'll just do that. I know the picture doesn't look right, But the point is that now we have irrational roots, roots with radicals in them. All right, the third case that our discriminant is exactly equal to 0. Exactly equal to 0. Back up, let's peek at that quadratic formula. If this equals 0, think about what you're getting. Negative b plus and minus 0 over 2a. So this whole part doesn't even matter, adding 0. We're going to get a nice looking fraction. It's still real. It's going to be rational. There's only going to be one of them, really. There's two different ways to describe it. You're going to get negative b over 2a. That's really only one root. But a lot of books will describe this as 2 equal roots. 2 equal roots. You'll see why in a moment and definitely make this connection. When these are graphed, what happens is that the parabola will hit just once. And of course I missed here. Bring that down. Hits in one place. Maybe this hits at 5/2. That's all you get is one root. One intercept, one root, and it's rational. And then our last case, we talked about the discriminant being positive. We talked about the discriminant equaling 0. The last case is that the discriminant is negative. So a number under the radical like negative 9 or negative 20 or negative anything. Well, that's new for us. We don't typically deal with these, but now in this chapter we are going to. So an interesting thing happens here. Our roots are no longer real. So one thing you'll see is that some people will describe them as not real. There's still going to be 2 of them. They're unequal. But instead of not real, we're going to bring into our vocabulary that our roots are imaginary. And officially, the description would be 2 unequal, complex conjugates. And we will learn more about that in the coming days. When this type of parabola is graphed, this is what we see. No x-intercepts. It does not hit the x-axis. That's why they're not real. They're not real. We can't look at our x-axis and say, what are the roots? They're not real. All right, so let's do some practice. I'm going to scooch this down. So our discriminant, we're working with the discriminant. Equation for the discriminant is b squared minus 4ac. If the discriminant is 64, look up at the chart. What kind of roots do we have? If you said 2 unequal, real, rational, in any order, you are correct. What if our discriminant is 17? Look up at the chart and describe the roots. If you said 2 unequal, real, irrational, you are correct. Number 3. What if the discriminant is 0? 1 real rational root, you are correct. You could have also said 2 equal real rational roots. Both are correct. Number 4, what if our discriminant is negative 12? A negative under the radical. So we know that is not real. A better answer? 2 unequal complex conjugates. There's that word conjugate again from chapter 3. Let's look at the pictures. Maybe pause the video for a moment. See if you can look at these pictures and tell me what the roots are like. Pause the video, try them, and you'll see the answer in just a moment. Calling this one irrational because it doesn't quite hit perfectly and I'm suspicious. Officially, we'd need the equation, but you get the idea. Number 8, last but not least, looks like the intent is it's hitting right there and right there perfectly. If it's perfectly, 2 unequal, they're real and they're nice, rational values. Good, let's keep going. So on the next page, we want to find the discriminant, then determine what the roots are like. We're going to describe them based on the chart. And then part C, we're actually going to find the roots. So this is going to either be by completing the square or the quadratic formula. Okay. Now it would take a long time to do all of these. So I'll see how the time goes. It may be that I leave a few blank to do with you tomorrow. So first let's just go all the way down and find the discriminant. So we're going to do this all the way down. That's what this section's about. Oh, that's terrible right there. B squared minus 4AC. No radical, just B squared minus 4AC. So we need to know in all of these values, all of these equations, what A, B, and C are. Here A is 2, B is 7, and C is 0. Here we'd have to bring over 3x squared minus 5x plus 3 equals 0. And A is, B is negative 5, and C is 3. So we'll do that all the way down. Let's find some discriminants. B squared minus 4 times 2 times 0 is 49. B squared minus 4 times 3 times 3. We've got 25, positive 25, minus 36. And our discriminant is negative 11. Number 22 from the book. Get your values of A, B, and C straight. Plug them in, figure out the discriminant. You might want to pause here and do the rest of the page, discriminant, and come back and check. Watch out for this double negative. This becomes 9 plus 40. Another double negative. Notice everything squared is positive. This was positive 9. This was positive 16. This was positive 25. Be careful there. Discriminant down here is 48. One more on the page. A equals 1, B is negative 4, C is positive 4, B squared is positive 16. So we've got 16, oops, that's a 4. 16 minus 16 and a discriminant of 0. Special case. Okay, we've gone through and found all our discriminants. Check. Now we want to say what the roots are like. I'll do that in red. This is the chart. You really want to get very good at the chart. You can't use it during the exam, the tests, the quizzes. So picture these numbers under the radical, just in your mind. If I have a 49 under the radical, it's a perfect square. So I'm going to have real, it's going to be rational, and there will be 2 unequal real rational roots. What if I have a negative 11 under my radical? Well, that's going to cause that imaginary situation. 2 unequal complex conjugates. You and I know that that negative under the radical is not real. Not real. Third one down, 49. Oh, we already did that one. 2 unequal, 49 under the radical. Definitely real, definitely nice. 48 under a radical. Definitely real, but it's not going to simplify, so it's irrational. And last but not least is 0 under the radical. Well, it's still real. A 0 under the radical leaves me with nothing to add and subtract, so that's when I get 1. And it comes out very nice. Negative B over 2A. All right, so let's do a little review from yesterday now. Let's just try one of these. I'm going to choose, actually, let's do x squared minus 4x minus 8. So let's do and find the roots for this one right here. So I'm going to use the quadratic formula. X equals negative b plus and minus square root b squared minus 4ac all over 2a. And I'm really all set up because I've already got my a, b, and c. So I'm going to put negative of negative b in, 4 plus and minus. And now my discriminant, which I've already figured out, I'm going to put that 48 right under there, all over 2 times A. So this work over here is shortened up a little bit. This one's going to simplify. See if you can get ahead of me. Two plus and minus 2 radical 3. That's the answer in simplest radical form. If I plug these into my calculator, just as a curiosity, 2 plus 2 radical 3 is approximately 5.464. 2 minus 2 radical 3, I have negative 1.464. And if I graphed the equation y equals this, then I should notice roots close to 5.5 and close to negative 1.5. So if you have a moment, I would recommend doing that. Let's find the roots for this one as well, this x squared minus 4x plus 4. So x equals negative b plus and minus square root b squared minus 4ac, our discriminant, all over 2a. All right, using the values from over here, b is negative 4, so negative negative 4. We already figured out our discriminant. Oh, it's 0. Awesome. All over 2a. So we get 4 plus and minus nothing all over 2. Which is just 4 over 2, which is 2. What do you see here? One real rational root. Actually, I should do the same here. What did you see here? 2 unequal real irrational roots. You don't need to draw the squigglies all over your paper, but the description fits the solution. This next page is a quick check for you. So I would say, pause the video, try these true-false questions, and see how you do. Pause the video now. Okay, I hope you checked your answers. If you have any questions on any of these, put a question mark next to it and ask tomorrow. And down here is just a spot for you to practice understanding the chart. The better you know this chart, the quicker you're going to be at understanding discriminant and quadratics and parabolas and what roots are like. That was the goal for today. Describing roots based on b squared minus 4ac. So use this chart for yourself. Maybe come back to it in another day or try it right now. I'll see you tomorrow.